Hello and welcome for another episode of Let's Learn Electronics with Radioshack. So this time we are looking at experiment number 75, non-inverting two-power supply amplifier. So now we're getting into the good stuff, and we are actually amplifying audio signals. The last video was about amplifying DC signal. Now we are doing AC signals. Okay, so let's have a detailed look at that schematics at the bottom. So let's zoom in. Yes, that looks good. I think it's big enough for our purposes, but I can make it even bigger. All right, beautiful. Okay. So this is your op amp, and this is it's non-inverting because the plus is the non-inverting input, and the signal comes to the non-inverting input. So that's why it's called a non-inverting amplifier. Let's just look at the input is an earphone used as a microphone. So it's actually a microphone. This control is actually just a pot. So here you have a voltage divider. Okay, so you have this piece of the pot is one resistor, and that's the second resistor. Okay, so if the 27, the wiper is at the top, you get the full voltage. Okay, so it's just a voltage divider, this thing. Voltage divider, very easy. So the op amp, this is the op amp. So this is the power supply, positive side, and this is the negative side. This is the output at 67, and 68 is the minus input, or the inverting input. And this setup is the 67 going back into the 68. That's the feedback loop. Okay, so that's RF, this one, R1. And the R2, if you looked at my previous videos, it's what I call RI. So this is classic setup. If you want to refresh your memory about this setup, you can look at my video about amplifying a DC signal. I'll put a link to that video right now. Okay, so let's talk about the power supply. So here you have a dual power supply. So if you imagine that this is actually ground, 119. Let's say this is ground. So here at the top, at 63, you're gonna get 4.5 volt, positive 4.5 volts. And at the bottom, the 70, you're gonna get, can you guess? This is ground, 4.5 minus 4.5 at 70. So minus 4.5. And that's almost it. 67 is the output. Well, the only thing that remains to talk about is that transformer speaker combo here. You may wonder why do you need a transformer here at the output? It's because the speaker has a very low impedance, 4 ohms or 8 ohms. So if you were to connect 67 directly to 29 and then 30 to ground, the speaker would load down the amplifier. It would be asking too much current. The nice thing about the transformer, it kind of acts like a buffer. So because the amplifier, what he would like to see as the load, this guy, as the load, he would like to see something with a high impedance, higher resistance. Let's say 5K ohms. That he would love to see. And we can do that with the transformer. We can have the impedance between 3 and 5 to be 5K, the impedance between 1 and 2 to be 8 ohms, assuming the speaker 8 ohms, and then you would have maximum transfer of power. So that's exactly what we want. So if here you have 5K and here you have 8, it means that between 3 and 5 you're going to have more turns than between 1 and 2, which is shown here in this picture. It's a step-down transformer. So what happens that you have maximum power transfer to the primary, in the primary, and you also have maximum power transfer in the secondary. So that's perfect. And what also happens is that the voltage here between 3 and 5 is going to be greater than the voltage between 1 and 2. Because of the change in the turns, the voltage is going to go down, and again, due to the change in the turns, the current, because of the change in the turns, because of the decrease in number of turns, the current is going to increase. And this is because the power doesn't change between the primary and the secondary. The power at the primary is the same than the power at the secondary. So if you knowing that P is equal to VI, if V decrease, I, the current, has to increase. Okay, that was a long one, but that's the you see those output transformers a lot when you do like tube amps. An alternative to this setup would have, instead of a transformer, you could use a voltage follower, where you have you can use an op amp like this, but you don't put any resistor in the feedback loop. You just connect directly, and you get a voltage gain of 1, but you gain quite a bit of current. So you could have done that instead. Before we go to the bench, let's have a quick look at the voltages without any AC, so just DC. And so I build that thing and I write down what I see. So no AC, only DC, blah blah blah. So the power supply on the plus side is 4.7, on the negative side is 4.8. V69, where the input AC comes to, is 0 volt, of course. V68, 0 volt, because it's always supposed to match V69. And I talked about that at length in probably the previous video about the DC amplification. As soon as you put a feedback loop, the voltages at the two inputs are always equal. Okay, so whatever you put on one, the other one is going to match it. And V67, so that's the voltage at the output. At the output of the op amp is 0.44, so 440 millivolts. And it is whatever is needed to make V68 equal to V69. Okay, so now let's go to the bench. I'm on the bench, and what I did is that instead of connecting the microphone, the earphone, I'm connecting a signal generator. So I don't know if you can see my signal generator here. So I got this from Amazon. It came as a kit. It's probably 15 bucks. Highly recommended. Okay. And here I'm connecting the positive side with a cap to basically decouple the DC portion, because this guy outputs DC at the same time as the AC, which is not ideal. Anyway, okay, so let's turn it on. Okay, so it comes out of the speaker. I hope you can hear it. I know it's pretty annoying, but you can. This signal generator, you can. This is a sine wave, and you can change the pitch, whatever. Okay, but let me turn it off. because it gets annoying real fast. And here I have my scope. So this scope is also Amazon special or eBay special. This one came pre-built. I mean, you can also have it as a kit. And I hope you can see that line. Yes. Let me. Okay. Yes. And this is also maybe $20. Again, highly recommended. You can work with audio signals, no problem. I think the maximum is 100 volts peak to peak, so don't use it for anything too high in terms of voltage. But it's very useful. $20, you can go wrong. So that's what I'm going to use to measure the input and the output. So let me connect. I think the ground is 119. Yes, 119. And 69 is the input. So let me turn it on. Okay. So that's how it looks like. Okay, so this is 5 volt per division. Okay, 5 volt per divisions. And this is the input. So let's switch to the output. And we'll see how it looks like. So the output is 67. Okay, you can see huge difference. So now it's completely off the scale. I have to change the scale. So now the scale is 50 volts per division. And as you can see, it's clipping, it's saturating, which is to be expected. But anyway, this show. Okay, let me turn it off. Yeah, okay. And I forgot to say when I was doing the study of the circuit, the amplification factor, which is equal to the resistance in the feedback loop divided by the input resistance plus 1, is equal to 100 plus 1, so 101. So you have a amplification factor of about 100, which is a lot. So anyway, I think I'm going to stop here. And as you can see, if you get this 130-in-1 electronic project lab, which has the very interesting op amp, and it has lots of experiments in the manual, so you can really play around. And I'm going to try to go through almost all of them. And if you can get one of those guys in the lower left there, one of those signal generators, $15 on Amazon or eBay. And if you can get one of those, a scope like this, you don't need those fancy scopes that cost $300 or something. I have one, I never use it, because this is more than enough. This is perfect for audio work. Audio work, perfect. And very easy to use as well. So if you have those two tools plus this thing, then you're all set to learn. Alright, I'll see you around. Bye.